Now in the last video lecture we have learned about the concept of path length and displacement. In this lecture we shall learn about the concept of average velocity and average speed, and instantaneous velocity and instantaneous speed. Now average velocity and average speed. Now when an object is in motion, its position changes with time. But how fast is the position changing with time, and in what direction? This can be described by a quantity called average velocity. Now average velocity will tell us how fast the object is moving in a particular time interval. Now average velocity is defined as the change in position or displacement delta x divided by the time interval in which the displacement occurs. For example, if we have a motion of an object in a straight line, say as motion in a straight line, suppose of an object, point object from this position to this position, then the position of this object can be described by one coordinate axis, that is the x-axis. So when the object is at this position, suppose at t1, the object is at this position x1, and at t2 the object is at this position. So the object changes its position from x1 to x2 in the time interval t1 to t2. So the average velocity in this case will be defined as, it is denoted by VAV. This average velocity is defined as the change in position or the displacement. Now we have done displacement. It is denoted by delta x, and now divided by the time interval delta t. And this delta x we have learned before. It is equal to x2 minus x1. And the time interval delta t, this is equal to t2 minus t1. So this is the average velocity. It is the displacement divided by the time interval. Now the time interval is the time between the t1 and t2. Or we can also denote this velocity by simply writing a bar on top of the letter v. Now this will denote average velocity. And from this formula we can find out the SI unit of velocity. Now the SI unit of this displacement is meter, and the SI unit of this time is second. So the SI unit of velocity is meter per second. There are other units which we use in our day-to-day experience. For example, the kilometer per hour, which is used in speed of vehicles. So this is also the unit which is used to measure velocity. Now, like displacement delta x is a vector quantity. It has got magnitude and direction. So average velocity or velocity also is a vector quantity, and it has direction as well as magnitude. And as we've done earlier, if your object moves in this direction, then this is taken as positive. If it moves in this direction, then it is taken as negative, minus and plus. And if it moves up, then this takes as positive, and if it moves down, then this direction is taken as negative. So since we're studying motion in a straight line, we will not concern ourselves with vector notation. Otherwise, these vector quantity, will be represented by vector notation. So in this chapter, since we're doing motion in straight line, the aspect of the vector can be taken care by the positive and the negative sign. Now let us consider the motion of a car in a straight line, and the position time graph for this motion is shown in the figure or in the graph. And as we can see from the graph, at 0 second the displacement is 0, and at 5 second the displacement is 10 meter, and at 7 second the displacement is between 25 and 30, and in this case it's 27.4 meter. So this is the position time graph of the car moving in a straight line. Now if you're asked to calculate the average velocity between these two time intervals, 5 second and 7 second, then we'll have to use the formula given earlier. That is V. This is equal to delta x by delta t, and delta x is x2, which is the final position, x1, which is the initial position, and t2 is the time when the object is at position x2, and t1 is the time when the object is at position x1. Now from the graph, at t1 equal to 5 seconds, x1 is equal to 10 meter. The displacement is 10 meter. And at t2 is equal to 7 seconds, the displacement x2 is equal to 27.4 meter. Hence the average velocity can be found out by putting the value of x2 and x1 in this formula, and t2 and t1 in this formula. So x2 is equal to 27.4, x1 is equal to 10, then t2 is equal to 7, and t1 is equal to 5. So if you calculate this using a calculator, you can get the value of the average velocity, which comes out to be 8.7 meter per second. So this is the average velocity in the time interval 5 second and 7 second. Now geometrically, the average velocity is the slope of the straight line P1, P2, connecting the initial position P1 to the final position P2 as shown in the figure. So this will actually give us the slope of the line P1, P2. Now by slope of the line, I hope you understand this concept. If you have a position time graph in this way, then if the line is straight, then this line has no slope. It's not slanting, so it has no slope. In this case, the slope is 0. But if your line is slanting, so from this position to this position, then this has a slope, and the slope is usually given by this say delta x and divided by delta t. So the slope of this line is given by delta x by delta t, which in this case is the average velocity. So now this line has a slope. So starting from this 0, if you go in this direction, the slope of the line increases and it reaches a maximum value at this position. So if your line is in this direction, then it has a slope, and if it is a straight line, then it has no slope. Now if your line is in this direction, so if it's slanting in this way, then this we say has a negative slope. So if your straight line is slanting in this direction, in this way, then this has a negative slope. So in this case, the slope for this line here, the slope is 0. For this line here, the slope is positive, and for this line here, the slope is negative. So this slope of the line, okay, delta x by delta t, or we can say this p by b, that is tan of this angle, that is known as the slope of the line. So for this line it's positive, here it's 0, and for this line it's negative. So you need to remember this concept. And here in this example, we have the position time graph to be like this, and at this p1 your time is 5 seconds, and the displacement is 10, and at this position p2 the time is 7 seconds, and the displacement is 27.4. And this straight line here joining this line P1 and P2, this is known as the slope of the line P1, or the average velocity. So the slope of this line will give us the average velocity. Now we can also find the average velocity between this time interval 0 and 5 simply by drawing a straight line and calculating the slope of this straight line. Okay, say P0, P1. So if we calculate the slope of P1 or P0, P1 of this straight line P0, P1, you'll get the average velocity. And in this case also you'll have to take the displacement delta x, which is this one, and the time interval delta t, which is from 0 to 5. So this is the time interval and this is the displacement. So if we take delta x by delta t, then this will be equal to slope of this line P0, P1. So that will actually give you the average velocity. So you need to remember this concept. Average velocity is the slope of the straight line joining the initial position and the final position. Now the average velocity, like displacement, I told you it is a vector quantity. So it can be positive, negative, and 0. Just like displacement, like we've discussed earlier about displacement, can be positive, negative, and 0. So similarly, average velocity can also be positive, negative, and 0. And in the figure, it is shown the position time graph of the motion of an object in 3 cases. For A, this is the position time graph of an object with a positive velocity. As you can see here, the slope is positive, hence the average velocity is also positive. And for the case B, here is the motion of an object with a negative velocity, and again here you can see the slope is negative, hence the average velocity here also is negative. And in the case C, you can see that the position of the object is same. Okay, it's not changing its position. So in this case the velocity is 0, or the object is at rest. So the velocity can be positive for case A, negative for case B, and 0 for case C, just like displacement. Now the average velocity involves only the displacement, but as we have learned earlier that displacement and path length, they are different. So to describe the rate of motion over the actual path length, we introduce another quantity called the average speed. Now the average speed is defined as the total path length traveled by the object divided by the total time taken by the object to travel that path, and it is equal to your average speed is equal to total path length divided by the total time taken to travel this path. So the total time taken. Now this average speed, it may be equal or maybe not equal to the average velocity depending upon the direction in which the object is moving. So if the object is moving in the same direction and the magnitude of displacement is equal to the total path length, then the average velocity will be equal to the average speed. But that is not always the case, as we're going to learn in this example. So we take this example: a car is moving along a straight line, say OP. Now it moves from O to P in 18 seconds and returns from P to Q in 6 seconds. Now what are the average velocity and average speed of the car in going, in the first case, from O to P, and the second case from O to P and back to Q? So here we'll have to calculate the average velocity for the first case from O to P, and the average speed from O to P, and the average velocity from O to P and back to Q, and the average speed from O to P and back to Q. So let us take the first case, that is case A, when the car travels from O to P. Now the time taken here, it's according to the question, it's 18 seconds. So from this graph, the initial position at O, your x1 is 0, and at P the final position is given to be equal to 360 meter. And according to the question, the time it taken to travel from O to P, that is the time interval, this is equal to 18 seconds. So here we can calculate the average velocity as delta x, or simply I'll write x2 minus x1 divided by, this is delta t, and x2 minus x1 is 360 minus 0, and delta t it's 18. So what we'll get here is (20 meter per second). So this is the average velocity from O to P. Then we can calculate the average speed also. Now the average speed, again you have to know the total path length. In this case the total path length is same, that is 360, and the total time taken, so I'll write average speed so the total path length here from O to P it's 360, and the total time taken it's 18, so here also it will be the same, 20 meter per second. So here you can see that since the car is traveling in the same direction and the total path length is equal to the displacement, hence the velocity, average velocity, and the average speed is the same. But in this next case, which is case B, so in case B the car travels from O to P and then from P to Q. So in this case, the average velocity will be different and the average speed will also be different. So the average velocity in this case, here your x1 will be equal to 0 meter. Now x2, since it's traveled from O to P and then from P to Q, the final position will be at Q, which is equal to 240 meter. And we know that from O to P, the time taken is 18 seconds, and then from P to Q, the time taken is 6 seconds. So the time interval in this case, delta t, will be equal to, from O to P it's 18 and from P to Q it's 6. So the time interval here will be 24 seconds. So with this formula, or with this given in the equation, we can calculate the average velocity, which is 240 minus 0 divided by the time interval delta t 24. This will give you 10 meter per second. So this is the average velocity. And since the displacement is positive, this is taken as positive. Then we come to the average speed. Now average speed, this will have to take the total path length. So the total path length in this case will be from O to P and then from P to Q. So the total path length, I'll just write it here, it will be from O to P, it's how much? 360. And then from P to Q, it will be 360 minus 240, and that will be equal to 120 meter. So this will be the total path length, then divided by, now the time interval, again it's 24 seconds. So if you add this and divide it by 24, what you'll get is 20 meter per second. So here we can see that the average speed is 20 meter per second and the average velocity is 10 meter per second. So here you can see that these two quantities, they are not the same. So only when they travel in the same direction and if their path length is equal to the displacement, then the average speed and average velocity will be the same. Now suppose if you have another case, your car say travels from O to P and then from P to O. So this means that the displacement is 0. So the average velocity will be, since x2 is equal to x1, this will be equal to 0. But the average speed this will be equal to the total path length, which in this case will be equal to 360. From O to P is 360, from P to O is also 360. So if we add this 360 and 360, you'll get the total path length. And in this case, the total time will be from O to P, the time taken is 18, and from P to O, the time taken will also be, say, 18 seconds. So the time taken will be 18 plus 18, and in this case you add these two, you will get 720, and again if you add these two, you will get 36 seconds, and this is equal to 20 meter per second. So the average speed here is 20 meter per second and the average velocity is 0, since the displacement is 0.